And welcome to SanfordFlipMath. This is PreCalculus. We are working through the Demana Foley Kennedy book, 4th or 5th edition. And we are in the Trig chapter. We are now about to take our right triangle trig and take it to the X and Y axes. Pretty familiar stuff here to notice. We're on an XY plane. Now here's the thing. We need to talk about what does an angle look like on the XY plane, on the XY axis, on a graph. And so first thing we need to note is that angles are about rotating, and we're rotating from the positive x-axis. The positive x-axis is referred to as the initial side. So anytime we're talking about an angle in standard position, and that's the terminology your book uses, the angle starts, excuse me, on the positive x-axis, and then we're going to rotate to the other side of the angle. Now, if we're rotating in a positive direction, then we're going counterclockwise. So, positive direction is counterclockwise. Negative rotation would be clockwise, and so it's possible to rotate this direction. Okay, and so we're talking about an angle maybe going that way. Okay, and so again, this is negative. Okay, so this might be negative 120 degrees. This might be positive 35 degrees, something like that. Okay, wherever the angle stops is called the terminal side. Okay, so again, the initial side is always the positive x-axis, and then the terminal side is wherever the rotation stops. So if we go negative 120, that's negative 120, sorry, terminal side is right there. Terminal basically just means end. Okay, so if you go to the bus terminal, that's where the bus routes end. The movie Terminator, he was sent back to end John Connor's life. Okay, so terminal side, end, or we say that disease is terminal. So in other words, it's going to bring your life to an end, something like that. Okay, and then probably worth noting that there are angles that are co-terminal. Well, co just means same or that we share. So like if we're talking about co-pilots on a plane, they are pilots on the same plane. They are together. Well, co-terminal angles are angles that share the same terminal side. Okay, so an example of that might be, here's 35 degrees, okay, which we already did. Well, what if I go all the way around 360 plus another 35 degrees, 395 degrees? They are coterminal. What if I go all the way around 360 and another 360, so I'm at 720 plus 35, so 755 degrees. Or maybe even if I go backwards, negative, well, if 360 would get me all the way around 325, so negative 325. Okay, so 395, 755, negative 325, and 35 are all coterminal. Okay, so they stop in the same spot. They stop in the same exact degree measure. Okay? All right, so far so good. Now, what if we take then, well, before we do that, let's just stop it and make sure that we know what's going on here in terms of this all of this terminology. So let's draw an angle that is negative 26 degrees, and then we're going to do two coterminal angles. One that's negative and one that's positive. Okay? All right, so let's do negative 26 degrees. So the initial side is here. You don't have to always label that, but I am going to do that right now just so we're clear. Okay, and again, negative rotation. We always rotate around 0, 0, around the origin or the pole. Negative 26 is going to be something like that. So here's negative 26 degrees. Okay. if I want a terminal side, now, so again, this is the terminal side right there, okay? If I want to get two coterminal angles, so one of them's got to be negative, so I'm going to go in the negative direction. Well, here's 360 and another 26, so 360, well, I went negative and a negative 26, so negative 386 degrees. Okay, so that's one terminal angle. And the other one, I want a positive one, so that means I need to go this way. Okay, so that's positive 360 if I go all the way, but I'm not going quite all the way. So this is going to be 334. Okay, all right. So that's what we're talking about in terms of going forward or backwards, positive or negative. Probably worth noting that I can also do all of this in radians. So for instance, I could rotate pi over 2 clockwise, or counterclockwise, excuse me, or I could rotate negative 3 pi over 2, and those are coterminal as well. Okay? So again, pi over 2 is 180 over 2, so 180 over 2 is 90. Okay? Okay. Well, to actually do trig on the coordinate plane on the xy axes, then we need to somehow go to the triangles that we're used to looking at. Okay? So I need to make a big deal out of what a reference triangle looks like. Okay, so here is an example of a triangle on a graph, and notice that here's the angle that we were just talking about, rotating from 0, 0, around 0, 0, rotating from that positive x-axis. Okay, so here's that initial side that we were just talking about. Here's that terminal side that we were just talking about. Okay, and the cool thing about this is if I'm on a graph, then this point is, you know, we have like a little address, a little location for that sucker. Okay? Well, x is a measure of how far to the right we are. Y is a measure of how far up we are. And then because x, the horizontal distance, and the vertical distance are always perpendicular to each other, that's automatically a right triangle. And then we have a relationship between x squared and y squared, and normally we call this c, and for whatever reason, when we get into trig, we actually start calling it r. And I really think that's because we tend to relate this to a circle going around 0, 0, and so it's like the radius of that circle. Okay, so let me back up just to get that off of there. Thank you. And so this is r, and so we'll call this r squared. So, and you're very familiar with this relationship, Pythagorean theorem. So if it's a right triangle, and it is. Okay, now here's the catch. I don't have to be in the first quadrant, but my triangles always have to be oriented in a certain way. Okay, so the angle always has to be at 0, 0, and it always has to be made with the x-axis. Okay, so one possible triangle is here. Now, it could be taller and narrower, it could be flatter and wider. Okay, those are all possibilities, but in terms of where is it located, it has to be similar to that. Well, likewise, it could be located over here. It could be located over here. It could be located over here. So if I'm in the first quadrant, okay, just a reminder of the quadrant numbers, and I don't know why we are consumed with Roman numerals when it comes to quadrants, but there we are. Okay, 1, 2, 3, 4. Okay, remember that 4 is 1 before 5, so there it is. So reference triangles are always part of what I refer to as this bow tie. Okay, so please note that if you are looking at trig stuff, you're never going to have a reference triangle like this. Okay, that ain't it. Okay, you have to have this angle at 0, 0. Okay, and so that would be this angle, or this angle, or this angle, and those four angles are referred to as reference angles. Okay, so a reference angle, okay, I got a little excited here with my notes. Okay. A reference angle is always has its vertex at 0, 0 at the origin. It always has its initial side, well, I'm sorry, it has a side on the x-axis, and it's always between 0, let me actually put some words on here. I'm tempted to just put interval notation, 0 and 90 if we're in degrees. Okay, so in other words, between 0 and 90, or if we are in radians, between 0 and pi over 2. Okay, that's for reference angle. Okay, so for instance, okay, let's copy this guy and come on. This computer's working really slowly today. Let me just make sure. Yep. Okay, I'm good. Okay. Let's do that. Awesome. All right, and let me fix this back up. Cool. All right. So let's say we have theta. The actual theta value is 110 degrees. Okay, so from the initial side, we're going to rotate to here. Okay, so theta equals 110. Okay, well, what I want to do is write a reference triangle, draw a reference triangle for this. Okay, the reference triangle always has to be made in that kind of, one of the sides has to be on the x-axis. Okay, one side has to be on the x-axis. One side has to be perpendicular to the x-axis. And then this has to go to the 0, 0. Okay? So the question now is, what's the reference angle? Well, the reference angle is whatever angle is made with the x-axis. Okay? So again, made with x-axis. Okay? In other words, a side has to be on the x-axis. So here's the reference angle. Well, how many degrees is that? Well, if I were going to go all the way to here, that'd be 180. So I already went 110 of that. So I'm guessing it's 70 degrees. Okay? So that reference angle's 70 degrees. Okay? What if instead we rotated, okay, new theta. Okay? Actual theta, let's say, is negative 45 degrees. Okay? So from the initial side, I'm going to rotate clockwise 45 degrees. Well, now the reference triangle has to look something like this. And, well, what angle is actually being made with the x-axis? Well, it's 45 degrees. So theta was negative 45. The reference angle is actually 45. Okay, again, this is part of the bow tie. Okay, remember the bow tie looks something like that. So it's one of these triangles. Well, that was terrible. Sorry. Okay, so something like that. And that fourth quadrant triangle was that one. Okay, so it's got to be one of those in that setup. Okay. All right. Well, let's do a little example. And so we'll pick something similar to what you see in your book. And I'm going to give you an ordered pair. So let's do 3, negative 7. Okay. So 3, negative 7. And what we're going to do is find all 6 trig values for this. Okay, so in other words, I want the sine of theta, cosine theta, and the rest. Okay, so what I'm going to do is from that ordered pair, okay, so again, 3, negative 7, I'm going to draw my right reference triangle. Okay, so there it is. Okay, I'm going to label some lengths on here. Okay, now first of all, this is the x value, so that's 3. This is the y value, so that's 7. Now, please note it is below the x-axis. It is negative, so we're actually going to put that negative there. Okay, so that means that some of our trig values for this are going to actually be negative. Okay, because anything dealing with y is going to be negative. Now, the reference angle, the one with which we refer, careful of where your emphasis is, the reference angle is the one that's made with the x-axis. There it is. Okay, and now technically, now that's the reference angle. Technically, the actual angle that we're talking about, though, starts at the x-axis and rotates all the way around here. Okay, so that's the real theta. But the one that we're going to play with, the one that we're going to work from, is inside the triangle. Okay, so it's inside the triangle, made with the x-axis, etc. Okay, all right. Well, in order to do sine of theta, I'm going to look at this, and I'm going to do just like I would with regular sine. I'm going to do opposite, -7 over hypotenuse. Oh, I don't know the hypotenuse. All right, so we got a little more work to do. Okay, so again, a squared plus b squared equals c squared, or x squared plus y squared equals r squared. 3 squared plus -7 squared. Why did I put that in parentheses? Because I'm squaring the negative as well as the 7. Okay, so 58. So r is positive or negative, the square root of 58. Now, quick little note to self here. R is always positive. Okay, when we are working with trig values in this, in the coordinate plane, the hypotenuse is always positive. Okay, x's and y's can be negative, but we let the x's and y's be a negative carry whether the value is positive or negative. Okay, so -7 square root of 58 over 58. Cosecant is the reciprocal of that. I'm going to go back to where I did not simplify to do this. And the negative can go on the top, bottom, or in the middle. It doesn't matter. Okay. For cosine, same idea. Adjacent over hypotenuse, which we will rationalize the denominator. Secant is its reciprocal. Again, if I work with the one that was not simplified first, that actually works better. And then tangent is opposite over adjacent, and cotangent's that reciprocal. Okay? All right, so that's the basic setup when we're talking about ordered pairs. Okay? Now, a little bit of an extension here then. What if I'm actually talking about, let's say, the cosine of 3 pi over 4? Well, probably worth noting that the cosine of 3 pi over 4, well, pi over 4 is 45 degrees, so 3 times 45 is 135. So 135 starts at the initial side, goes over here past 90. Okay, so here's 135. And the problem here is, where's the rest of the information, right? I know the angle, and I know I could type this into my calculator. My calculator is going to say something like 0.707, well, negative 0.707. The problem with this is that's rounded, and I don't want to round. Okay. Okay. So, what's the reference angle? Well, if this is 135, 180 minus 135 is 45 degrees. Remember that this makes a right angle here. Again, we are part of the bow tie here. Look, you're focusing on this triangle. We are referring to this triangle. Well, excuse me, the other angle would have to be 45 as well. Now, so again, this is a 45, 45, 90. And then the other issue is, since we are to the left, this is negative because that's a negative x value. Okay? So, at this point, we can just do this by saying adjacent over hypotenuse. So adjacent would be -1. Hypotenuse is square root of 2. And I can rationalize this, so negative square root of 2 over 2. And again, the calculator would have done this, but that's that value. Okay? Okay. All right, I just want to spend a little bit of time putting some things together here. Okay, I really don't want to do that. And I don't really want to, oh, I did that on a unit circle page, sorry. It's all good though. All right, so we're just going to wrap this up a little bit for, this is again 4.3a. Okay, summary. Reference triangle, part of the bow tie. Okay. Reference angle has to be between 0 and 90, has to be made with the x-axis, and similarly always positive. Okay, so the reference angle is always one of these 4 angles. Oh, yeah, the other part, this was at the origin. Vertex is at the origin. Okay. The other thing I need to note here is anytime we're looking at a triangle in here, you know, like cosine is going to be, you know, about adjacent, and it's always going to be about x. Okay, so on a graph, cosine is always going to be about x. And what I mean by that is in terms of whether it's positive or negative. Okay, so since the adjacent side is always going to be on the x-axis, the cosine is always going to be about x. Okay, since sine opposite is always going to be over here across from the reference angle, the sine is going to be about y. Okay, it's positive or negative about y. Tangent, whether tangent's positive or negative, well, tangent's opposite over adjacent, it's going to be about y over x. And if we're going through 0, 0, y over x is really slope. So whether tangent's positive or negative is going to be about slope. Okay, so here's how I'm going to summarize all of that. Cosine is positive when x values are positive. So cosine is positive on the right where x values are positive. Cosine is negative on the left where x values are negative. Sine is positive where y values are positive. Sine is negative where y values are negative. Now this is a lot of information. You can come back to this and kind of peek at it again. Tangent would be positive where the slope is positive. Okay, now so like rise over run. Okay, so this is a positive slope in the positive slopes in the first and third quadrant. Tangent is negative in the second and fourth quadrants. Okay, and then one last thing to wrap this up, and that is a little mnemonic. And this mnemonic you can make up your own, but the idea is this works. And the phrase is all students take calculus, and what we're doing is we're going in order through the numbering of the quadrants. So all students take calculus. Okay, and what this does is it tells you where things are positive. So in the first quadrant, all of them are positive. In the second quadrant, only sine is positive. In the third quadrant, only tangent's positive. I should also say they're reciprocals. In the fourth quadrant, only cosine is positive. Okay, so this is just a speedy way to remember which ones are positive in which quadrants. Okay, so all students take calculus. That's going to become an issue, and this page kind of summarizes everything. So the signs, whether they're positive or negative, all students take calculus. and reference triangles, reference angles. Okay, well, I need to be done. I know I'm going to have an issue from Martez already. He's accusing me of making epic movie length videos. So, Sanford out. Bye.